Okay, now we want to do some of the examples for 1.1 rate of change and slope of a curve worksheet. So the first question is easy. You just average rate. You just find the slope between the 2 points will be the average rate. Simple for that. Maybe I just do quickly one of that. Say you want to do that, -1 and 5. So here is point -1 and 5 is here, right? Just find the slope between these two. AVR, average rate of change, is y2 minus y1, 6 minus -5, divided by x2 minus x1, 5, minus 1. It's 11 divided by 6. Estimate instantaneous rate of change at a point corresponding to x equal to 1, -1. Okay, so for this question, we use the mean value theorem. As I explain, the mean value theorem, let's say I want to do for this. 5 is this point. I need to choose 2 points that the 5 is in middle. So 5, 6, 7, two units you go up, you get to 7, 2 units you go down, you get to 3. So these 2 points, if you take average of these 2 points, instantaneous rate of change, x equal to 5, is the same as average rate of change between the 3 and 7. So y2 minus y1, y2 is 45, minus y1, which is 5, divided by x2 minus x1, 7 minus 3. 40 divided by 4 is 10. So this is the mean value theorem. Again, if you just look at that, instantaneous rate of change here, if you choose 2 points around that, the average rate of change of these 2 points, see the slope of this line and the instantaneous rate of change are the same, right? So if you choose this one to be 5, this one is 3, and here is 7, as long as the set 5 is between in the middle of 3 and 7, the average rate of change between 3 and 7 is the same as instantaneous rate of change at 5. These two lines has the same slope. Okay. Estimate instantaneous rate of change at tangent point indicated. So if you do that, instantaneous rate of change is the slope of the tangent line. What you do, you just find 2 good points. Let's say this point and this point. This point is what? Is 2, 2. And this point is 3, 4. Just find the slope between these 2 points, and then it will give you the slope of a tangent line, which is instantaneous rate of change. Now for each graph, try compare instantaneous rate of change. Okay, to compare it, let's say I want to compare C and G, right? I want to compare C and G. Of course, I put instantaneous rate of change or slope of the tangent line at G is more sharper, right? I have a higher, bigger slope here at G. So slope at G compared to C, of course, G has a bigger slope. The same way you can compare the other slopes, same way for A and B. So the summer average rate of change first 10 seconds. So from the 0 to 10 seconds, you just find the slope between that. It's very easy. For instantaneous rate of change, again, you need to use the mean value theorem. Identify if in this situation is instantaneous rate of change or average rate of change. So let's just do the first two. When the radius of the circle ripple on the surface of the pond is 4 centimeters, the circumference of the ripple is increasing at 21.5 centimeters per second. Means when the radius is that, the speed that this ripple increasing is that. So of course this is instantaneous because it's at 1 point, right? The instantaneous rate of change. Nico travels 550 50 kilometers in 5 hours. It's the duration of the time. You have a duration of that, there's 2 points. It's going to be average rate of change. Same way you can say for the others, average rate of change or instantaneous rate of change.